for the end. And if you can put your cameras on, if that's okay, and if you're comfortable, that would be great. And yeah, right, starting recording. So thanks everyone for joining today, the Science Spotlight at Valley Dow. I'm Gina, I'll be hosting today, and I'm a community member of Valley Dow. We like to call ourselves the growers. And for those that don't know, Valley Dow is a global and open community of researchers, students, people working in industry, investors, people that are interested in synthetic biology. And essentially, we are collectively funding and incubating both academic and independent research that is targeting environmental sustainability. So these science spotlights are a very important way for us to cultivate this community because it's essentially a platform we can feature the brilliant research that's going on, but also have a space, an open space for people to discuss and learn and get inspired. And yeah, it's very exciting because today we are joined by Dr. Jenny Molloy from the University of Cambridge, where we'll be discussing how Dr. Molloy and her research group, the Open Bioeconomy Lab, are helping to build a globally inclusive and equitable bioeconomy. So also wanted to add congratulations, as I recently heard that Dr. Molloy was appointed the lead of the biomanufacturing group at the International Center for Genetic Engineering and Biotech. I believe it's based in Italy. So congratulations. And yeah, I have talked way too much now. So over to you. We're excited to hear what you have to say.
Great, thank you very much. Yes, from September, I'll be splitting my time between the UK and Italy, which will be very nice, potentially, because I have not got any seaside or mountains here in Cambridge. So I'm
whereabouts in Italy?
In Trieste, in the north of Italy. It's basically next to Slovenia. So yeah, it will be good. And for anyone who's not heard of ICGB, they're basically a UN or research institute for genetic engineering and biotechnology that has 68 member states who are mostly low middle income and emerging economies. So yeah, my work, as you'll see in the next 20 minutes or so, is very relevant. So let me just share my screen. Hopefully this works. And I'm just going to apologize again that something is happening with my wired connection today. So if I do disappear, I promise I will be back shortly. I'm not sure what's going on. Normally this is the most stable way to join a Zoom call, but today it's not. It's not having it. So yeah, my name is Jenny, and I am based here in the Department of Chemical Engineering and Biotechnology at the University of Cambridge. So greetings from the UK. I'm going to talk a bit about work that my group does with open science and open source for decentralized biomanufacturing, and in particular, how we can increase the amount of engineering biology, synthetic biology, biomanufacturing practice in low middle income countries. Primarily, my group work with colleagues in Africa and Latin America, but we do also have some kind of new collaborations in Asia as well. So I'll talk a little bit, I guess, more about kind of why we do what we do. I'm not going to dig too much into the sort of technical aspects of our research, but welcome questions on that at the end. And then maybe think a little bit about kind of how this might fit into the type of thinking that Valley Dow has already done around growing these kind of sustainable and equitable structures for the bioeconomy. So yeah, and hopefully that will form the basis of a great discussion in the second half. So thanks again so much for the invitation. So a little bit about me, just so you kind of situate where I've come from. So I'm a zoologist by training. I did a lot of evolutionary genetics as an undergraduate, including with this fellow here, diamond bat moth. And then my PhD was actually in genetic control of dengue mosquitoes, which I did as a joint PhD at the University of Oxford, but also with Oxitec, which is a British biotech company developing insects that are basically sterile. And so I already had a bit of exposure to kind of the biotech industry through that. But simultaneously, I've been doing work with Open Knowledge Foundation, who are an NGO, a nonprofit looking at open data and open science, and I led their open science working group. And so those two sort of strands of my world collided after my PhD in 2015, and I joined Open Plant, which is a UK synthetic biology research centre, and I was the programme manager for Open Plant here in Cambridge before getting a fellowship from the Shuttleworth Foundation and starting my lab in 2018. So it's been a kind of, I guess, a convergence of scientific interests and an interesting kind of open source and open practices, and how sharing knowledge can be done more effectively, and what impact that has on the production of research and science, and how also to kind of open approaches could potentially get that science out into the world and benefiting more people faster. So as a kind of sideline to the research track, I've also set up a number of nonprofits, Content Mine and Biomake Space. I'm no longer involved in, but I am currently on the board of Beneficial Bio that I'll talk about a little bit later, and the Open Science Hardware Foundation, which is a US nonprofit that kind of tries to build out a more enabling ecosystem for people developing open hardware tools for scientific research. So that's a kind of snapshot of like where I've tried to combine the science and the open in my own career to date. And I think what I landed on was that, you know, I think my sort of specific interest in biotechnology and biology and open, the synthetic biology community is a very nice convening point for a lot of those ways of working. And so I guess it was no surprise that I kind of ended up there. But particularly the kind of what drives the work that I do is thinking about biology as the future of sustainable manufacturing of many things. As we all know, there's very obvious applications in medical technologies with vaccines, diagnostics, therapeutics, but also materials, energy. More and more products are being biologized, and that future is already here. We're seeing it, but it's not very evenly distributed. And there's a whole bunch of evidence that shows us this is to be the case. And if we look at kind of synthetic biology innovation and where research is being undertaken and published in synthetic biology, it's clear that the majority is happening in higher income countries. So of 24,000 papers containing synthetic biology, just over 1,000 are from LMICs, excluding China, which is actually the third highest publishing country when it comes to synthetic biology. And if you break that down even further, then in Africa, a very small amount of the literature is being sourced from that region. And that has knock-on effects also for innovation and particularly speed of innovation. So if you've got a strong research ecosystem, you're much more likely to be able to kind of translate that research and direct it towards new products. And we saw, you know, during the COVID pandemic, probably one of the biggest mobilizations of the world's research and development community towards a kind of very mission-oriented goal. And if you look at diagnostic innovation, you can see really that there's in 2021 at least, which I kind of guess is representative of how fast people are able to get diagnostics onto the market. You're seeing a lot in the kind of usual players, so North America, parts of Asia and Europe, Brazil and some of the bigger economies in the global south, but very little in other parts of the world. And so there's a clear, it's not just basic research, it's also knock on into innovation. And one of the ways that we can think about this is in terms of manufacturing capability and supply chains. So a major problem in biotechnology is getting reagents. I mean, there are many reasons why there's less synthetic biology that happens in certain parts of the world versus others. There's politics, there's economics, there's a whole bunch of things. But I'm sure many people on this call have a background in bench biology. And so we know that it's super important to have the tools of the trade to hand. You need pipettes, you need lab equipment, you need your enzymes, you need your buffers. All of this stuff is physical, tangible goods that need to be in the right place to do the research. And for many colleagues operating in Africa, Latin America, and elsewhere, it's much more expensive to get those reagents than it is elsewhere in the world. And so this was a challenge. This is basically the challenge that my lab group attempts to solve in different ways. And why did we choose reagents rather than the many other things for which there are also supply chain challenges? Well, because we feel like the cold chain shipping requirement just adds an extra element of difficulty. I spoke to someone recently who's been attempting to get some very nice enabling toolkits into countries in Africa for quite a number of years, and the hurdle has always been the need for dry ice shipping because it's super expensive. Very few couriers will do it. Even if they say they'll do it, whether it ends up there still frozen is another thing. So this is the problem that we address, and this map shows exports of laboratory reagents in 2018. So the darker blue the country, the more exports, the lighter green, the fewer exports. And exports are not a direct proxy for manufacturing, but they're not a bad one. And so you can see that this pattern mirrors quite well what we saw on the previous map around COVID diagnostic innovations. And so the challenge is if you're not kind of manufacturing locally, then you're dependent on other countries for that whole supply chain. And although I mentioned cost being an issue, a real problem is time to delivery. So if I order something to my lab bench in Cambridge, I can expect for most things to get it in the course of 2 or 3 days. For our colleagues in Cameroon, they feel fortunate if it arrives in 4 weeks. And we've had stuff take 2-3 months to get there before. Again, if it gets there still frozen, if it gets there still functional. And so if you imagine trying to do biotechnology innovation, we all know biology, the default is it doesn't work. You have to repeat multiple times, change your design, change your strategy. If you're thinking about like synthetic biology projects for biosensors, you're going to have to go through multiple iterations, right? This is why we have a design, build, test, learn cycle, is because we understand that you're not going to get it right the first time. But if every time that you cycle around the DBTL route, you need to order new fresh reagents and different components, and you're waiting kind of 1, 2, 3 months at a time, you can imagine that the speed with which you can do any research at all, but especially get that research to a point where it's ready for real world application, can be massively slow. So this is a real problem. And this, it's just a kind of personal story from Lenshina Agbo, who we worked with in Cameroon, setting up a lab there, and is now a PhD student in the UK, who's talking about her experience of moving between those countries and how the gap in terms of research outputs and access to tools like enzymes and equipment couldn't be wider. And so in Cameroon, Lenshina was working on malaria infections in pregnant women. And in the UK, she's working on sexually transmitted infections and understanding some basic biology, but also thinking around translation. And so this is a real issue for the individual researcher. And if we look at a health systems level, it's also a major challenge. And so we've sort of seen the impact on R&D, we've seen the impact on innovation. But if we think about access to things like diagnostics, therapeutics, vaccines that are built on biotechnology, this is also a problem if you're not manufacturing locally, in particular in the hopefully rare but obviously close to mind experience of COVID, where you have a huge demand. And the director of Africa CDC talks about how, African countries had funds to pay for reagents for diagnostics during the pandemic, but they couldn't buy them because the manufacturing capability was outside of Africa. And many of those countries were, of course, taking the manufactured goods as the priority for themselves first. And so this dependency is something that has major implications across different sectors of the economy, health being a key one, but it's not the only one. And so the idea is that we could try and increase access to these technologies more globally to solve some of these problems. As I said, this is one piece of a problem. There are many, many other reasons why there's not access to diagnostics in certain places. There are many reasons why there's not more research happening in certain places. But this is one part of the challenge that we felt, I felt that I might be able to do something towards. And so when we think about access, I think there are 3 components that are important to deliver access to reagents. One is technology. So we need accessible products and manufacturing technologies. We need networks for knowledge exchange and distribution in terms of building communities that will actually ensure that technology is used and is useful. And then also we need enterprise. So there's, communities and grassroots organizations can do so much in the research space, but ultimately researchers do actually just want to kind of buy some enzymes and get on with with the job at hand. And so we're also interested in kind of what mission-driven companies can do to deliver access to these technologies at scale. So I'll talk a little bit about how we're doing all 3 of these things. And just to say that the goal is basically increasing resilience and autonomy through a distributed supply chain. So moving from what we have now, which is a fairly centralized supply chain for most biotechnology tools and reagents, through to something that's more decentralized and eventually distributed in a sense that it's a robust network that is kind of very resilient to certain nodes being down due to issues that they're having in that geographic region, or kind of certain actors exiting from the space. So that's the goal. And so I just wanted to talk very briefly about principles, so how we're going about it, and how open plays a role in that. So I think when we're working with colleagues in low middle income countries, there's a real need for close collaboration and co-creation to make sure that any technologies that are being developed through our research are appropriate for the context in which they're being used. And so this is a real coordination challenge. We need to coordinate people and things, speaking to each other, doing stuff, having research materials in the right place at the right time. There's difficulties in navigating asymmetries of resources and power and information. So how do we kind of be equitable in those partnerships? A real challenge for us is documentation as well, because biology is a very kind of sticky subject in terms of knowledge. So it's a lot of know-how, it's a lot of kind of how to do things in the lab. It's often very difficult to figure it out from just a written protocol. You kind of need to watch someone doing it, and that's a real challenge when you're trying to do stuff across continents and collaborate together. And a kind of key principle for us is reducing dependencies. So I already kind of hinted at this in terms of the idea of countries that are not currently manufacturing these reagents being very dependent on other countries, which if it works, it works. Right now, it doesn't work. The system is definitely broken. And that's why we're trying to kind of find an alternative. So whatever we do, though, should not kind of reinforce those dependencies. So we try and think about manufacturing and toolkits as a way to kind of provide the means of production. So we provide toolkits such that people can produce enzymes. Those enzymes also enable them to produce new parts for the toolkits, and so on in a cycle. We kind of consider also from the start, like, what's the end game? What are the risks of what could happen to make this entire research effort useless? How can we kind of mitigate some of those risks and think about from the start a more kind of community governed and decentralized effort that doesn't have a single point of failure, for example, my lab. And that's something we're still building out. And also, how do we balance this kind of local autonomy, but also recognizing that globalization is not going away and you're never going to make everything locally. So I think enzymes and certain biologics make a lot of sense. Probably not everyone's going to start manufacturing with peptides. And so there's kind of, when you start dividing up the tools into different categories, there's somewhere it makes a lot of sense to kind of have this local autonomy, and somewhere really you're dependent on sorts of global supply chains and I guess economies of scale for some of these aspects. So how does openness kind of help us achieve this goal in this way? Well, first of all, I just want to talk about what I mean by open. So most of what I'm going to talk about in the technologies part of this presentation is universal access. So how can you provide specific molecular tools that are unencumbered by intellectual property? And that means that anybody can use them, reuse them, build on them, commercialize them, manufacture them, sell them. But there are two other important components. So one is kind of universal participation, trying to increase involvement of stakeholders in shaping the projects using those tools. And that is something we'll cover a little bit in the community section. And then also collaborative production. So how can you get multiple partners working together for a common goal? And kind of all of these things make up an open source or open science ecosystem, an open science project. It is important to get the licensing right, but the rest of it is also critical, we feel, to deliver what we want to deliver. So why open source anyway? I think because in our case, it does accelerate the R&D. So it reduces friction in access to knowledge and materials being a key one. So we also produce a lot of materials that are shipped under an open material transfer agreement, which for anyone who's unfamiliar is like is a contract basically about how you can use DNA or cell lines that you receive. And very often it's quite restrictive. And so we try and kind of work around that. We really want user innovation. So, I enjoy producing tools and technologies that I hope other people will go on and do great things with. And so we also want more diverse ideas and to expand the pool of developers of synthetic biology innovation to more countries and more minds, more people across the world. And it also enables you to kind of focus on the value add. So we're not kind of obsessed with protecting things or not telling people about things, but more focusing on how we can really do the best we can with the know-how piece that I already mentioned before, how we can build those collaborations and community and build trust and buy-in. Why not use open source? Well, I mean, fortunately, a lot of the work that we're doing does not have an enormous need for capital. So there are definitely times at which there's a need to protect in order to receive investment. Also, if your goal is to maximize profits, Monopoly is incredibly effective at that. So that if that's your sole goal, sole aim, then open source probably not for you. There's probably some cases where that's not true, but and then need to defend or control. So if you have either a need to stop your innovation being co-opted or kind of closed off against your wishes, there maybe is a need to kind of take a a modified open source approach, and there's different ways you can do this legally, and some projects use patents to try and maintain values of quality or equitable distribution. I can give some examples if anyone's interested. Also, if it's not very useful and you're going to spend a lot of time documenting something that no one else is interested in, that's also a bad reason to go open source. So you have to be a little bit smart about where you invest time and effort when you're making open source technologies. So in terms of what technology my lab is producing, I guess our sort of flagship project is the Open Enzyme collection, which is a series of DNA, is a classic synthetic biology toolbox of enzymes that are useful for molecular biology, reporter proteins, and other useful kind of purification tags, solubility tags, cleavage sites, and of course regulatory DNA. And it's all aimed at basically expressing protein. So although recombinant protein technologies have been around since the 80s, there are many countries in the world where actually there's very little recombinant protein expression happening. And so the production of this toolkit is attempting to kind of leapfrog from having the ability to kind of get one specific plasmid from a gene and do your thing, to having actually more choice, but not needing a kind of, decade of experience and a hugely well-equipped lab to actually work on these basic production systems. Obviously, what we're producing are the kind of tools to do biotechnology and molecular biology, but you can swap in any enzyme or protein that you like into the collection. And so we're hoping that user innovation takes off. So it's nearly 200 interchangeable elements. And we've got one specific collection for research and diagnostics, which basically takes a subset of the coding sequences that are very useful for that, and has been a little kind of curated in terms of what we're providing for affinity tags, for example. So thinking in terms of low-cost diagnostic production and low-cost purification of enzymes, putting in binding tags for very low-cost materials like silica, like cellulose, thinking through kind of removing as many reagents from the production process as possible. And that is really what kind of a lot of the rest of my lab is working on. So either manufacturing protocols or working on some kind of diagnostic redesigns. So I won't be covering that in this talk, but I'm happy to chat about it at the end. But I just wanted to use this as an example of a particular collection that we've put together for a particular purpose, and we're hoping to do more of those. So one project that we're kind of taking small steps towards at the moment is working for local production of toolkits for gene editing of plants, for example. And this collection has a syntax so that you can kind of combine things much more easily. We're attempting to now get some resources to retrofit the syntax onto previous parts that we've made. So this kind of forms one big collection that people can work with. So that's a kind of example of a piece of open technology that we've made freely available, but we now need kind of networks of people that are actually going to use it and help each other to do that. So the toolkit itself is in around 500 labs in around 50 countries. As you can see, we have also not made full penetration into the African continent just yet. There are a number of countries that we're still getting the toolkit to, but we have some really good partners there, at least in East and West Africa, who are kind of working on building out those links. So we hope to kind of get it, because of course Africa is a continent where, as we saw before, there's, if anything, the most need for this manufacturing to happen. But it's also a place where, there are some real resource constraints that need to be overcome. So in terms of building community, we set up reclone.org, which is a global community for equitable access to biotechnology that has a fortnightly community call and works together to improve the collection, publish protocols, etc. And so the whole point of this is to kind of reimagine the supply chains for these reagents, so they no longer limit the creativity, ambition of impact of scientists in the global south. And we've done a lot of training as part of that. So we've trained over 250 scientists in different parts of the world. We've hosted 9 internships in Cameroon and also 2 master's students as well in Mobile Lab Biotech, which is one of our key collaborators. So we're kind of building these informal communities that meet frequently, that have online spaces where they can publish things, and also performing these in-person groups. For example, the group in Argentina is actually from about 5 different countries in Latin America, and they've all just applied for some funding so that they can continue exchange and training between the different countries to enable use of the reclone collection. We publish stuff on protocols.io, so there's a reclone group there where you can find different protocols for easy expression of enzymes. And here's just a couple of projects from the community. So in Chile, Isaac and Tamara have been using the reclone collection to express enzymes for RT-LAMP for SARS-CoV-2 detection, and they've published that work in 2021. Felipe has now continued this work, but applying it to potato virus, which is an issue in Chile and other parts of Latin America. So kind of taking and improving a technology for a local challenge. And here in Cambridge, I have 2 PhD students who are working on LAMP CRISPR diagnostics for typhoid fever, again, with a mindset of local manufacturing of the reagents and potentially also a device. So that's the kind of community aspects. We have a toolkit, it is out there, and we're attempting to create a close-knit community that can use it, and that are also starting to apply it for what we hope will eventually be impactful applications. In terms of enterprise, so the thinking was basically we need some companies that are going to manufacture these things and sell them to researchers locally, such that researchers that do not want to set up production in their own labs do not need to. And the main pilot with this has been in Cameroon with Mboa Lab and my nonprofit Beneficial Bio. So we've developed a whole lab space there, which is actually now 2 lab spaces, both a communal lab for people to come and do their research, and also a production lab for reagents. They run a lot of training in the communal lab in particular, mostly PhD students from universities that are coming in to learn molecular techniques. They build their own hardware. These are some gel transilluminators built in Cameroon. They produce enzymes and reagents. So there's a PCR here run with locally produced TAC and buffers, and they sell those reagents to other places. And it's just a couple of examples of their local products here. So DNA polymerase, master mix, and gel loading dye, and they're kind of slowly expanding their range, and also having other suppliers that they get in contact with. But it's interesting because not only is the technology kind of designed for Cameroon in the sense that the polymerase is storable at ambient temperature. You can see it's dried down, and there's a label that says you can store it at room temperature for a number of months, it turns out. But they also have made some business innovations. So you can do mobile money payments, which is very important, particularly for students. Most of them do not have bank accounts or credit cards or means of paying for reagents from international companies. Obviously, it's fast delivery because the stuff is already in Cameroon, and so there's some advantages from a kind of a less technical side, a more just kind of doing business, getting hold of stuff side. And so this picture on the right is just a little video of the production lab that they've got set up there. And currently they have 11 research institutes that are their customers, 18 bioinnovation lab users, and about 50 researchers that source reagents from them. And we're aiming to expand also into East Africa. We have some USAID funding to help with that. And yeah, more places. So I'm coming to time for the talk, and I really want us to have time for discussion. So I'll just kind of wrap up to say that the future vision of this work is really that through this combination of technology, community, and enterprise, we can kind of serve synthetic biology researchers with the reagents that they need to do their work. And hopefully that will lead to more ideas, more people, and more places that are creating this fairer and more equitable bioeconomy, which I understand is effectively the mission also of ValleyDAO. So I kind of, in terms of where my research sits and the mission of ValleyDAO, I think it's really that we're kind of trying to create the tools such that those SynBio researchers who might enter the system with their cool research that can impact the world can do the work they need to do. And so I always feel like a lot of where I situate myself and think about my work is sort of one step removed from the end goal, but really kind of creating that those tools and technologies and the ecosystem that will enable the kind of more applied research to thrive. And sort of ultimately, we'd really like to see that in low middle income countries, thinking about that cycle of dependency, that researchers there have the ability to kind of mine their own biodiversity for useful proteins and enzymes, insert them into the toolkit, use low cost and readily available open and accessible technologies, could including high throughput systems, to really kind of combine and do larger scale experiments than are currently possible, be able to kind of rapidly test and prototype. We do some work with cell-free systems in that regard, and really integrates kind of technologies that are just becoming more democratized and accessible, whether it's AI, whether it's big data, whether it's kind of integration of chemistry with biology. But a lot of this stuff, the cost is lowering, and a lot of it is kind of the transfer of knowledge, but also the transfer of the tools to actually apply these digital techniques to biology in the real world. So I'm hoping that we kind of have a future where there's the ability to have this hyper-local system of discovery, innovation, and biomanufacturing, and that we can help bridge some of the really cool innovations in digital tools with the kind of the pragmatic reality of needing physical and biological materials on your bench in order to really work with that. So just a final wrap up is that most of our work is geared to increasing access to the tools that people need to do synthetic biology. Without these things, you can't really do it. And so that incorporates technology, community building, and also thinking about enterprise and how we kind of make this more sustainable in the longer term. And I will stop there and just say thank you to my excellent group and all the people and collaborators that have worked on this with us. And yeah, looking forward to a great discussion for the next 25 minutes.
Wow, that was a very inspiring, very impactful talk. I think the research you're doing is incredible. I don't think you're just a step back. I think you say you are, but you're really not. I think it's really, really incredible. I'll let people put some questions in the chat in the meantime.
Yeah, or feel free to raise your hand and unmute. But I have a ton of questions, but yeah, I'm keen to hear other people's opinions first.
Yeah, I have some too. I don't know, Morgan, you want to go first or up to you?
Go on, you go first, Hannah.
Okay, cool. So my first question is, when you're establishing these partnerships, are there any conditions or not prerequisites, but how do you know how can you maximize the success of that partnership when you're making these intercontinental collaborations?
Yeah, it's very difficult. I mean, definitely we've had partnerships that have gone in, different directions from the original intention. I think that's just natural. Often we've started with a pre-existing relationship or a kind of being members of a community and sort of starting from that position of trust already and then trying to build on that. Often it's kind of also people that, you personally get along with and kind of have a shared set of values. I don't mean just on a social level that you can chat, but I think there's definitely finding people that share a way of working is important. So otherwise you can end up quite rapidly in clashes of, we are trying to do things in a certain way where there's a big emphasis on equity and sharing and openness and transparency, and having someone who's more used to working in a slightly more kind of distant or closed way. It's not necessarily a bad way of working, it just doesn't work in combination. And so finding people with shared values is very important. And yeah, we've just been fortunate that we've really kind of, and I think they're easy to spot in the sense of how they describe what they're doing. And I think part of the challenge is always looking at how someone describes what they're doing and then trying to understand if that is actually how they're doing it. So a really great partnership we have is with the Ethiopian Biotechnology Institute. So actually biotechnology and emerging technologies betting in Addis Ababa. And that came about basically because I read their website and was just blown away by kind of the vision that they had for connecting. They did a whole, from 2016, they've done basically an entire review of the Ethiopian biotechnology ecosystem and bioeconomy, and kind of thinking through from figuring out who's doing what in which universities, what equipment exists, the really pragmatic stuff, through to the kind of higher level of how does biotech fit within the economic and social priorities of the country, and how can we really use it as an engine for economic development and kind of improving health. And so I just really liked the approach that had been taken. And so I reached out to them and was able to arrange a visit. And then, 4 years later, we've had a number of projects and some really great work. And that kind of link in terms of how we view bioengineering and biotechnology as an engine to kind of drive clean growth and health. Like it's that kind of shared, I guess, vision that's, I think, held things together. And also, you know, they're a really very productive bunch and very open. And so yeah, I think that's worked out really well. So they're definitely that. So I think, and just testing the water, like it helps to have small projects to start off with, and then you can kind of like figure out if it's working or not from there.
Awesome. Yeah, I think it's worth mentioning something I'm not sure if you're aware of. I know Diana was thinking about this as well. And I think we also had Christiana, who was part of this initiative. But basically, we've been doing a similar thing. So it's great to hear that that they've done it for Ethiopia specifically. We're trying to map the landscape of SynBio in Africa and Latin America.
Nice.
On an individual country level, which is obviously a ton of work. But we've got like 5 key pillars that we've been focusing on. So I think the political landscape, the financial landscape, so mostly like fundraising and grants, the startup landscape, what support is available, then the academic landscape, of course, I almost forgot. And then the final pillar was one we added in after like many discussions with the socio-cultural landscape, and recognizing that there are unique and specific challenges in these regions that, you know, mean that science doesn't happen in the way that it does in other places, you know, that we have the privilege of doing so. So yeah, that's kind of like the project that we've got ongoing at the moment. We started it in, I think, late February, early March. And I've been having weekly meetings ever since. And we've got a couple of forums coming up. So for both Latin America and Africa, we're going to be doing like a day-long workshop where we'll have a few, you know, keynotes talks as well, but mostly like really interactive workshops, getting stakeholders across the ecosystem to give their own inputs and really have their voices heard. And yeah, we're hoping to be able to put together like a comprehensive report. Sorry about the noise. We're hoping to put together a comprehensive report and hopefully eventually a digital resource where people can go on and based on their country, they can, you know, see what opportunities exist and are available to them. The main problem we're trying to address with that is like, okay, similar to how you are with the developing tools for research, is seeing that, okay, there's lots of talent and inspiration in these regions, but a lot of it tends to leave and then go to places like Europe or the US, which is great for us, but you know, it's not keeping and retaining that talent in the region where it really needs it the most. So yeah, that's kind of the vision behind the project. I just wanted to kind of shamelessly show that.
No, that's great. I'd be fascinated to see the results. Well. Yeah, I'd be fascinated to see it. I mean, it's work that needs doing, because like I said, there's been a number of countries I know that have done their own internal reports, but you do have to look, you know, you then have to kind of have the mindset of, right, I'm going to look independently for these things, and having more of that in one place. I mean, there have been efforts within, you know, engineering biology community to do sorts of road mapping and other exercises, but often Africa and Latin America kind of get dropped off the list. And so it's great. That's fantastic.
Yeah, it's one of the benefits of having a scrappy community who have a lot of time on their hands.
Anyone can join as well. So it's a very collaborative event. Any students, academics, anyone, industry workers. Yeah.
Oh, nice. Well, I'd be happy to share that.
Yeah, definitely. We just got a question from Serafina. Thank you for sending that in. Serafina is wondering whether you've engaged with any science policymakers. If so, could you elaborate on your experience and thoughts about the links between this project and science policy? And how much do you think science policy may have to change in order to achieve your goal of making SynBio open source worldwide?
Yes, that is an excellent question. And actually it was sort of my original fellowship that I got from the Shuttleworth Foundation. Part of the pitch for that was effectively that you have all of this kind of high level bioeconomy policy and strategy documents that are coming out, which were saying kind of incredibly ambitious goals. But if you speak it for regions where if you speak to the bench scientists, they're like, well, yeah, but I can't get a tax. So kind of how can I fulfill? So part of it was about trying to kind of recognize that some of these very pragmatic challenges seem kind of, you know, very mundane and inconsequential, but actually, you know, they are kind of intimately linked to the ability of these policies to deliver. And often those policies are not geared towards aiding kind of the practical nature of science. They're more about having, visions of how science links with other things and having kind of visions of how funding could happen. So I have engaged in the sense that I've done some work, for example, with the World Economic Forum, Synthetic Biology Council, and we did a couple of policy reports that were aimed at sort of trying to illustrate how policymakers could think about embedding different values into synthetic biology. We're about to publish one also on the global landscape and sort of particularly in terms of the global south, how to think about synthetic biology policy. I've done less of it than I intended to, I think, when I started in 2018, but I think that's partly because the pandemic kicked in I started my fellowship in 2018, but my first postdoc started in 2019, and then we hit 2 years of COVID. And then I got very pulled into policy work, but it wasn't policy specifically around science. It was policy around diagnostics and local manufacturing. So I've kind of spent quite a bit more time in that space in terms of the policy angle and looking. And I think there, I'd say the key takeaways, which are possibly, I guess, applicable more broadly to other kind of translational science areas, is that you really need, particularly in my space, which is local manufacturing, you need a real intersection between science policy, innovation policy, and the government procurement policies and trade and industry policies, because if any of those are misaligned, then stuff goes wrong. So a small example in South Africa is that a lot of science funding goes towards medical research on diseases of public health concern, TB, HIV, etc. So you end up getting really top quality research. South Africa has an excellent ecosystem for these types of things. You get spin out companies from universities that then get supported by government innovation funding, but they're producing products that basically only the government will buy because it's public healthcare products. And then when it comes, and actually the Department of Trade and Industry in South Africa says you should preference local manufacturers and a number of other groups. But actually when it comes to the health ministry buying the products, if they're cheaper to import, then they'll buy them from outside. And so there's been a number of South African manufacturers that have effectively got successful products to market and passed all the regulatory hurdles, only to have to pivot their product or start exporting it because they can't make the sale locally. And so I think there's a disconnect there in terms of different government policies. So I think that's my sort of takeaway snippet from having done some policy work, is that you need people to be talking to each other and joined up, or it doesn't work. And we're seeing exactly the same thing with open source tools for science, in that you need both the funders to be aligned with the idea that they should, fund this and that there's a return on investment for them to fund open tools. But you also need kind of the government agencies and universities to be procuring the open tools. Otherwise, there's no pipeline. So I think if we want to kind of see open source tools spread across the bioeconomy, then you really need, from a government side, those two things to talk to each other. You also need private sector to buy the tools as well. But I think for research, at least in a lot of places, the majority of research is either funded by governments or it's funded by kind of international donors. And so that is a critical thing. People, again, procurement policy, super boring. No one thinks about it, but but it's actually very important.
Yeah, this is one thing that I personally am really passionate about addressing through Valley Down. The whole decentralized science movement is, pushing, enabling people to actually actively support this. Because as you said, a lot of it is government or publicly funded, and I'm sure lots of people would want to support this if they could, and participate in growing emerging markets. Who doesn't want to do that? It's both impactful and financially beneficial for the individual. So. Yeah, I've seen that we've got a few other questions in the chat. So we were going to start with Josh's question. Diana, do you want to read that out?
Yeah, so Josh sent a comment. So thanks for the presentation. After the training in April in Kenya, currently in the process of generating tech, I think from what I got is one can use what is locally available to make things work.
Yeah, so Joshua took part in our Enzyme manufacturing masterclass in Nairobi in April and is now going to be making some reagents there at Kenyatta University, which is where we're sort of building another bioinnovation lab and kind of looking. So I'm really looking forward to working with Joshua on all of this stuff in the coming months.
Awesome. And Miguel, I see you've had your hand raised for a while. Sorry about the wait.
Yeah. Hello, can you hear me?
Yes.
Yeah, thank you very much, Gina. It's really amazing career and really, you know, like a very, you know, I'm amazed about all, you know, the community you are growing up and all the projects you are working. So yeah, so I'm basically joining just to, you know, like ask you questions about how you know, like build these huge communities, how you get, you know, like supporting from, you know, like from different governments, from university and from industry, because basically I'm also interested in open source software technologies. So I've been working sort of like 10 years, and now I'm in the phase just to apply for funding and how to negotiate, you know, like open source like software or tools to industry, but you know, because industry wants to protect the IP, how it's so you negotiate that part and how you sort of create value for the products of, you know, the company that may support, you know, your open source software technology, and you know, like how also you to engage with like the government, or also once you create these tools, how these tools will be used by, for example, students, or you know, like someone in an hospital, and how you sort of like do some sort of long-term support, because you know, like I feel that we were in these projects that are supported for 2-3 years, and then there's no more long-term support. So you publish your paper, you publish your data sets, you publish your open, you know, like source coding, but yeah, then after if there's no more funding, then there's no more follow-ups. Yeah. So yeah, I mean, those are like various questions, but mainly about how you sort of like get like long-term support for your open source software technologies. Yeah.
Yeah, that makes sense. So yeah, I mean, I think the communities are not huge. I mean, it depends how you define huge, right? But if you look at some of the open source software communities, they are actually enormous. and if you look at kind of the biotech community as a whole, it's massive. So I think in terms of like the community building side, it's time, and also proactive community building and management is how you kind of get to scale. We're still at the beginning with Reclone. In fact, our community manager for Reclone, Yankee, is on the call here. So she's kind of doing a lot of that building work. But I can say, so I've been involved with, I helped set up a community in 2015-16 called the Gathering for Open Science Hardware. And that's now about 800 people, and it's on about to have its third community elections. They've kind of now got, you know, a community governance process, and things have kind of, you know, spun off. And now it kind of, I could step away entirely and it would be fine. Like so I think to your point about, you know, how do you sustain things? It is difficult in terms of operating at a research level and funding. Like I definitely say quite a lot of our stuff has been fairly bootstrapped from reasonably small amounts of funding. But it's trying to think about like, what can we put in place now such that if all the funding fell away, that we have some hope of things sustaining. So we're really focused right now on getting our collections out to as many other labs as possible, because that means that, you know, any of those labs has a chance to kind of get a small amount of funding and keep things going. And so I think this is where I am interested in decentralized models, of not relying on one single source of either funding or of kind of management or of knowledge or of kind of ownership, because that inevitably is going to fail in our current system. You have to have multiple people who feel like they have enough ownership of the project to make it live on if one of the nodes kind of fails. I mean, I might decide tomorrow that I want to, you know, give up and go gardening and do a totally different career or something. But as
Oh,
Oh no.
just wait for, yeah.
Yeah, hopefully she'll come back. But thanks for the question, Miguel. It's a really good one. And we got most of the answer.
Maybe we could.
Whereabouts are you based, Miguel?
I'm I'm currently based, well, I'm working at UCL. I do open software technologies for surgical navigation tools. So I'm developing, like these Python-based libraries. And one of the challenges we are actually facing is how we, like get funding to, like support or software. And, like how also to engage with hospitals to hopefully sort of like anonymize the data sets that we can train like these AI models and how we can sort of address for example like abnormalities in the data sets and things like that. So yeah, I mean that's like how you negotiate this kind of like I guess products that will be useful for the hospital, for the universities, and then how you sort of follow up with them. I mean, I'm at that stage. So yeah, and how how, for example, you reach out, let's say NVIDIA that will maybe support with some of the hardware, but then how you maybe, like engage with hospital who has a GE, ultrasound scanner, and because of course GE is mainly working with their own products, they are not keen to open source the technology. So that's where you need to start negotiating how you create this kind of open source software tools, open source software data sets and things like that. Yeah.
Awesome. No, it's really great to hear about you. I'm
Sorry
conscious
that I
that
dropped.
no problem, Jenny, no problem. We got most of it, so it was a good response anyway. I'm conscious that we've only got 4 minutes left, so I wondered if we could have a quick chance to read out Kamesh's question, and then we'll have to wrap up.
So there's first a comment, lowering the barriers for access to reagents and raw materials is also going to up this ecosystem to increase regulation. How can the open bioeconomy community tackle this complex relationship to balance openness with regulatory and biosecurity concerns?
Mm-hmm. Yeah, I think it depends on what level you're talking about openness. So we get asked this question a lot, but I think, so the type of technology that we are opening is basically the ability to faster and better do recombinant protein expression. Now, the US has been doing recombinant protein expression since the 80s, right? And the regulation has been very much in place. It wasn't originally, like there was controversy, there were meetings at SLMR, there was a whole thing with recombinant protein expression. But that is now very established and there are regulatory kind of pathways in place. So precisely for the technology that we develop, I would argue that, this is a well-trodden path. And in most places that we work, there are already existing contained use regulations and other things that perfectly cover the type of application that we're putting the research to. That's for my piece. Of course, the idea of us enabling other people to do the research is that they may then have other technologies, which are perhaps more complicated from a regulatory perspective. But I think, the sort of democratization of this to lower middle income countries, there are some very kind of particular biosafety challenges around particularly sort of the capacity to dispose of a hazardous waste appropriately when you're in a resource constrained position. Like there are some very specific things which do need to be overcome, but I think the idea that democratized biotechnology that will be used by low middle income country researchers is inherently more of a biosecurity risk than the same technology being used by somebody in a higher income country is a little bit arrogant. That we should kind of, really speak about regulation on a technology by technology basis. And I think, openness, we are increasing access in terms of time and affordability, but if somebody was a bad actor, they could get hold of this stuff by just paying more and waiting a bit for it to be shipped. So I would argue that the bio risk that we're generating through my particular work is negligible in comparison to the potential opportunities and benefits. I'm not speaking for all kind of biotech and synthetic biology applications there, but that's my approach to how we go about things. And we always embed biosafety and biosecurity in all of our training. And of course, it's a consideration and it's super important, but it shouldn't overshadow the benefits and the potential opportunities. And you have to have both going in tandem.
All right, I think we are at time. So Diana, did you want to close us off?
Yeah, we're just about to finish. I just wanted to ask one last question to everyone, just to, on a philosophical note, just to get everyone thinking. If you were a policymaker and you could, make a change or change some aspects of the regulatory system, what would you do? And let's say whatever you would change or want to change would change. What would that be? So yeah, just to think about that.
The tough one.
Yeah, I might need more than a few seconds.
Yeah, possibly. Yeah.
I think we're at the point, I think it's changing in Europe, but I think we're at the point now where GMOs are becoming more accepted, and the risks at least are being closely monitored, that we've had some time to assess them. So I'm quite keen on the safe. I want regulatory change on GMOs such that it enables people to innovate and do things that are beneficial, especially in developing regions that don't have so much access to food and nutrients and clean water, etc. But in a sense that it's safe enough, let's say, that we don't end up with a global ecological crisis as a result. So yeah, I think the regulation needs to catch up on that side, from my perspective.
Hamesh had a suggestion in the chat about IP and licensing stringency. And I think I would probably say it's not, I don't think this is going to revolutionize the scientific world or anything, but one policy change that I think could be made is to consider, having a range of a toolbox, if you like, of IP policies that are accepted by funders and accepted by scientific departments, and not kind of sticking to a single default or a single path. And I think that would kind of open up a lot more opportunities if there's more of a discussion about the right tool for the right job is how we think about a lot of technology and engineering, but it's also true in the policy space and it's also true in the IP space. Yeah, that's mine.
Yeah, no, I agree on that one. It's something we've been thinking about as well, is like the ability for a company to fundraise without having to have like defensible IP. And it's an interesting one as well, because especially on the scalability of bioprocesses, actually that becomes, in most cases, there aren't scalable solutions with bioprocess, and so that is much more defensible than the IP itself. And we should be paying more attention, I think, to process engineering and business models as well, which can make for successful.
Yeah, what is your value proposition, your business model, and is IP integral to it? And if it's not, then it shouldn't matter.
Okay, I think that would be a good time to wrap.
Yeah, and if anyone else has more thoughts, you can always join our community and share your thoughts in our Discord. So yeah, and thank you so much, everyone, for joining. Thank you so much, Dr. Jenny Molloy, for the fantastic talk and the fantastic discussions. And hopefully we'll see you all at our next Science Spotlight.
Thanks for the great questions and for taking the time to listen to what I'm doing. Do get in touch if you've got any more questions. Bye, everybody.
We certainly will. Thanks, everyone.
Bye.